Hello everybody. Hi. So what are we doing today? It will be doing the chapter like. I think midterm a lot of times this one quite important because from 4 finals I don't think light come out too much, right? Some of your school didn't even have chapter light, so that means your midterm quite important so that's why lah. Okay, let me show you what do we have. If you look at the notes, let me share with you the notes here. Okay, everybody get ready. I think you got this right. This one. Now, I tell you how to use the notes, okay? Now, of course, the question inside I'm not going to do all of them, definitely. So those are extra questions I put inside for you to revise. But please spend some time doing the question because those are all the questions I picked, which I think is important, which I think very good questions. A bit different than the usual questions you get in exam. I mean, not exam, a bit different than the usual question you get in exercise reference book. Those questions all I modified before and I picked before. So some of the questions a bit weird, a bit different. Those are the things that you always get tricked, always get surprised in exam. So that's why I want to do this. Okay. Now, first of all, you will see on the first few pages, right? This one here is a simple checklist for you because a lot of time, right? Now we always got two types of students. Number one is students that don't know. Second is students that don't know what they don't know. Okay, so some of you give me those excuses like, oh, I wanted to study one, but then I don't even know how to start. Never mind. A simple checklist here for you. You can see, right? Every subtopic. Now, I'll tell you what, chapter like 4 subtopics. Refractions, total internal reflections, lens, and mirror. 4 things only. Okay, this whole chapter they talk about these 4 things only. Refraction, total internal, lens, and then the mirror. Okay, so every topic, right, I actually list down the criteria for you. So what are things that you need to know? What are things that you cannot miss out? So you can see here, I give you some columns, right? So what you do, very simple. You can follow this as a study guide. Yeah, so you go through, right? If you say, okay, you know what? I know what happened for this. I know how this reflection occurs, right? Density different, speed of light change, and then causing bending of lights. And then now, when I say density different means what? We normally got 2 types, right? It's either you go to something denser or something less dense. Now, some people remember less than to denser, denser to less dense. You can remember this way as well, but you can also think about it this way, denser. Now, the answer is the final destinations. You go into something denser or less dense. Okay, now then what happened to your speed? They will change. And finally, the bending. Okay, so all these things, if you say, oh, this one I remember, so I put a tick there. And then drawing, okay, go denser, what happened? You bend towards, less dense, you bend away. So you can see right here, I give you all the short dances, short points that reminds you. And of course, refractive index, remember the N, formula, all together 4. Yes, so you tell me that, oh, all these things I can do, then you put a tick. And then for those who actually study one, you say, oh, I actually got study one, but I'm not sure whether I finish or not. Now again, simple checklist for you. You go through this, if you can take all this, you tell me, oh, all this I know, all this I can study, I actually went through already. That means you are prepared. Then you can move on to other chapters for your revisions. Okay, so this is the simple checklist for you to remind you what are the things that you need to know, what are things that you must know in a way. Then we got lens, and then we got mirror. Now, we can separate light into 2 parts. Okay, the first part is actually this one. You know what? Total internal and refractions, right? They always together one. Yes, because total internal refractions, there's this condition very important. In order for total internal to happen, right, you need to follow conditions one. So if your condition do not fit, okay, you don't fulfill all this, right? Simple. If it's not total internal, that means it's a refraction. That's why I say together, okay? Refraction always happens whenever you got different density. But then, right, you need to double check. Is there a chance that you might have total internal? That's why the condition, this one important. Okay, in order for total internal to occur, number 1, you must do this. Meaning the light ray must go from denser to less dense. So you check. Are you going from denser to less dense? If it's not, right, let's say less than to denser. For example, air, you go into glass. Air, you go into water. That one, no total internal, meaning you get refractions. Okay, now if it's total internal, right, number 1, denser to less dense, not done yet. Denser to less dense could be refraction as well. Second thing, you check this, whether your incident angle, is it more than critical angle? Now, this one thing that I get asked a lot. Every time people ask me, hey, where is critical angle? Now, there's no where. You see, critical angle, right, you calculate one. So how do you calculate this critical angle? you are using a formula of refractive index. This one, the 1 over sine C. Remember this formula, right? You substitute the refractive index inside, and then you calculate the C. So once you got the value for C, right, you compare it with your value for I, and you see whether the I value is it more or less. So C is like a number. It's like, let's say exam. You want to pass your exam, right? 40 marks, right? So 40 marks is your benchmark, but does that mean your exam paper must be all 40 marks? You can score 50, can score 60, can score 70, right? So if you got more than 40 marks, you pass. Less than 40, fail. Simple idea. So same thing here. If you got more than critical angle, then total internal, pass. If you are lesser, you only got, let's say for example, critical angle is 40, and then you only 90. 39. That means lesser, right? Lesser means you get refraction. So refraction is always happening one. You can see denser to less than to denser. Can bend away, can bend towards. If you go to denser, you bend towards normal line. If you bend away, right, that means less dense. Okay? But you need to double confirm. Is it total internal? This one double confirm. Get what I mean, right? Then all these explanations involving total internal one, Mirage, fish eye view, and then diameter, all kind of. Now after that, you got the lens. Lens, one thing very important is that you need to know about this convex and concave lens. Yes, convex, concave, typical drawing must know, calculation must know, and then the formula thing, especially this one, people always lose smart one. Because why? It seems very simple. It's just 1 over F, 1 over U, 1 over V, right? But the thing is, you need to decide yourself which one is positive and negative. Never mind, later I prepare for you. Okay? Then also, you got the compound lens part. Compound lens means the telescope, microscope thing. Now, midterm got chance to come on. But this one, I don't think I got time to talk about this. If I spend time doing this, right, then we will probably spend 1 hour doing this. And then I think it's less effective. But don't worry, I also prepare another video for you already. So after that, I can send you the video as well regarding how to draw all these telescope microscope. You can check that. Okay, so one thing, telescope. After that, mirror. Now mirror also, mirror and lens together one actually. You know why? Because mirror and lens terbalik. So I want you to remember they are always reversed. Because why? When we say lens, we got two types of lens. You got convex lens, you got concave lens. And then when we say mirror, right, you also got two. You got concave mirror and then convex mirror. But then the problem is they terbalik one. Now mirror and lens not same. Lens light go through, mirror bounce back. Concave lens, concave mirror, different. Convex lens, convex mirror, different. I mean not different, terbalik. Now remember we talked about what before, like converging, diverging. You remember this word converge, diverge? Now, what is the meaning of converging? When I say converging, it means what? The light ray, how? It's going to focus or it's going to separate? Converge means what? I mean, you can replace it with another word, okay? When we say converge, meaning what? Converge means focused. Focus means, right, where do you think the light ray will go to? They will focus to focal point. You get me, right? Now, diverge, they will separate. Okay, diverge will separate, meaning that the light ray go through, they will just separate. You get me, right? That's a simple idea here. So, converge, diverge, converge, diverge. You get it? So that's a simple thing. Okay? Now, so later, after that, you can see questions there. Now, then move on, you will see here. This is where we have all the, short notes. Not mean short notes. It's just the important thing that I feel like I must put inside. If not, you're sure confused one. Number one, I said refractions, total internal, always together, right? So over here, you can see, two of them versus, there's a spelling error here, this one. You change, refractions is not correct. Supposedly, it's total internal reflections. Okay? So, condition is, number one, you want total internal, must be denser to less dense. Angle, right, must be more than C. Okay, refractions, either way. Whether you go from less than to denser, denser to less dense also can. Then that's why, drawing how? If it's less to denser, you bend towards, then to less dense, you bend away. But then if it's total internal reflections, now your keyword is this. You know what I mean by reflections, right? It's like a mirror. Yeah, just like mirror reflection. So imagine you have a piece of mirror and then it bounces back. So that's why normally your angle same one. It's like you treat it like a mirror, but then the thing is, total internal happens in transparent thing, like water, glass, but they behave like a mirror. That's why it's a special conditions. Okay. Then after, of course, here telescope, microscope, all the special important points that I put inside here for you. Make sure you read through. Then after that, formula sheets, of course. When you're doing this set of exercise here, of course you ask, hey, those exercise questions, I don't remember the formulas how. There you go, everything here already. Refractive index formula 1, 2, 3, 4, and then for lens, right, formula 1, 2, 3. Okay, but remember, every time you're doing lens, right, you need to remember this. You have to follow this rule. Remember I said, right, the F and U and then V, sometimes they're positive, sometimes they're negative, right? Then you have to decide yourself, whether is it positive, whether is it negative. Object distance, right, always positive one. That one not a problem. The thing that you should be careful with is here. Okay, image distance and then also the focal length. Yes, two of them. Now, if you say image, right, then you follow. If the image is real, then you do positive. If the image is virtual, then you do negative. Yes, focal length, same thing also, converging positive, diverging negative. Okay, now speaking of this, remember real and virtual? You know what means by real image, virtual image? Can you tell the difference between real image, virtual image? Now, some people, right, always give me those answers like, oh, I don't know, right? My teachers say what? I look at the image. If they form together with the object is real, opposite is virtual. You remember that way, right? Sure, confused one. Because why? Mirror and lens terbalik. I give you the best example. For example, convex lens. Convex lens. Convex lens, right? The image is opposite to object. That one is real. Okay, but then when we come to convex mirror, the image same side with object is real. You see the problem, right? So that's why you remember same side, opposite side, sure gone because they terbalik. So what's the best way to do it? Simple. Number one, drawing. If you're doing ray diagram, right? Simple. If you see the arrow, I mean the image, if it's a solid line, that's real image. If it's a dotted line, that's virtual. Okay. Now, second, of course, people ask, then what is the real meaning of virtual and real? Simple. Image, real image, virtual image, right? One thing different to me. Real image are image that can be projected onto a screen. Means you point to the screen, right? The image poof, shows there one. You know what's the best example? Projector. You think about it. How does the projector works? You notice, right? If I point the projector to the wall, to the screen, there will be image show onto the wall, right? That's real. Virtual image, it means that image that you could see them. Okay, you can see it in so-called inside but then they never did project out. They never shows out. Okay, a simple example. Now, you look at this mirror here. What I have here is a plain mirror. Could you see the reflection in the mirror? Okay, now here. Can you see the reflection in the mirror? Can you see my face? This one? Now, this is virtual image. Yes, because why? Can you use a mirror to project your face? Meaning, let's say, mirror, you put your face here, pew, pew, on the wall. Got face come out or not? You think about it, you put like that, okay, you reflect your face to the wall. Are you going to get any face here? No, right? If yes, the mirror don't use, throw away, a bit scary. Exactly. So, most of the time, right, the image that you saw, you can see inside, so-called inside, right? That's called virtual. Okay, real image that can project out. But to be honest, very, very, very seldom we see real image. Right? Normally, what's the best example? Real image means projector. Okay, another example, camera. Camera also real image. You know why? Now, of course, camera don't project the image out. But the thing is what? Camera, they capture image. You think about it, the lens for camera, they capture everything and then they project to the screen, to the sensor. That's why they show you, right? Whatever you take photo, they show in the screen. Because why? From outside, they project to the sensor. Now, another example that also you can say we are having real image is, your eyeball. Okay, your eyeball. The lens is what shape one? Your eyeball. You touch and see. Is it convex or concave? This one. Does it come out or go inside? Your eyeball, not the eye socket, like your eyeball here. You can feel like come out, right? Come out means convex. Yes, convex lens is only lens. Okay, we got two lenses, right? Convex, concave, right? Convex lens is the only lens that can have that can actually give you real image. Now, of course, you say then if I look at the wall, does it mean I got something? No, it means that now let's say you look at anything now, the light go into this and then they project to the back of the retina. They go into your eyeball, they project to the back of your brain, right? Which means your retina. So image that forms on the retina is a real image. You get me now, right? So real image can be project, virtual cannot. Get it? Okay. Now, continue. Let me show you the questions, everybody. Let's see, questions. straight away lah. Okay, start with question, then you can see my right. Now I do this one first. Okay, we do a bit of refraction, total internal, and then we go to lens later. Right, diagram 4 shows a man spearing a fish. The man found that the fish appear closer to the surface of the water. Right, now obviously, right, you can see here is the real fish, here's the image, right? What kind of condition is this? Very typical questions, right? When you see like two objects, one shallower, one deeper, that means what? That is basically what we know as, what is it? Answer? Yep, of course, refractions. What's the effect of refraction? There you go. Refractions will cause the light to bend. So when refraction happens, what happens? Your things will look shallower, it looks closer. Now, refractions, right, they have this ability to magnify things and make things larger. That's why things larger, you will feel like they're closer. That's why whatever you see, this guy saw what? This person saw the image or saw the real fish. This guy saw the image, exactly. That's the thing. Now, another example is when you put a pen inside water, they look bended, right? That's the effect of refraction as well. Now, how does the above phenomenon occurs? We said just now, right? How do we get refractions? Simple, look at this. Why are we having refractions? You tell me at the first place, what is the situation here? You see your light ray, and then here. Notice, right? Why the light ray bending here? Simple, right? Inside, outside, different, yes? Inside, outside, different, right? What's outside? Outside here? This is what medium? Air, correct. What's inside? Inside means water, good. So what is the difference between air and water? Density different, correct. Okay, now I want to give you a best answers. I tell you what, the better answer to say, like, have you heard of the word optical density before? In these chapters, your teacher say, now most of the time, right, optical density and density quite similar one. Usually things with higher density, they also got higher optical density, but not a must. Later I give you another example. Not every time. I tell you how. Later I tell you how to determine whether the optical density is higher or lower. But here, this one, yes. Okay, I can say outside here I got air. Okay, outside we got air here, which means the density lower. And then water, inside here we got the water, right? Which means the density is higher. Are you following? Now, can you tell me the light is traveling from where to where? Listen to my questions. The light is traveling from where to where? Less dense to denser or denser to less dense? The light is traveling from, answer is denser to less dense. Okay, I should ask, the light go from water to air or air to water? Or to be exact, the light go from the fish to the eye or eye to the fish? Meaning, am I supposed to draw arrow like this? Or am I supposed to draw arrow like this? Of course, fish to eye. Hey, hello, what are you thinking? You know why you can see things? You know why you could see everything around you? Light go into your eye. Okay, can I draw like this? You know what does it mean if you draw like this? Eye, light ray come out. You're trying to laser the fish, like use your eye, like light ray, and then the fish just die. Then why do you need a spear? You can just laser the fish to death, what? Right? Remember, so what is happening? Notice or not, light is from the fish, go to the eyeball. Meaning from the water, go to air. Denser to less dense. What is next? Density different. What is next? No, bending too fast already. Always three things, one. Density different, they change what? When your density different, what they change first? Before bending, they change the speed of light. They make it faster or slower. And then, only you tell me bending. Now here, they didn't ask you what happened here. They asked you how does the phenomenon occur? So you give them the general answer. So why do you think refractions occurs? Because, okay, when light passes through medium with different, now instead of saying density, now you say optical density. Okay, when light passes through medium with different optical density, it causes the speed of light to change. Okay, there you go. Of course, you want to write, you say, hey, then do we not need to write the bending part? You want to continue writing also can, but this sentence is only 1 mark. So what they want you to mention is, you have to tell them the medium got different optical density. Perfect answer, you write optical density, your teacher cannot answer. Alright, and then the speed of light will change. You get me, right? There you go. Next one, in diagram 4, spear hit the fish image. What he need to do so that the spear hit the real fish? No lah, actually the best answer, right, optical density. When we talk about all these refractions, always optical density one. The correct answers. Now, if you write density, are you wrong? Most of the time teacher let you go one, but if some teacher very strict one, she will minus your mark. So that's why I say density, optical density, very similar, yes, but you need to understand the actual answer, the 100% marks one, right, optical density. Refractions are total internal, same thing also. When just now when I say total internal, you must go from denser to less dense. That one also you should write optically denser to optically less dense. But if you don't write, actually consider correct as well. But some teacher, they are more strict, they will minus your mark. So that's why when I give you, I give you like perfect lah. Make sure your teacher no chance to minus one. Okay. All right. So you, of course, you saw this one, right? You throw the spear like that. Is it going to hit the fish? Then what he needs to do? What should the fisherman do in order to hit the real fish? Aim where? Aim higher, lower? Aim higher got use me? Of course, aim lower, right? Aim deeper also correct. Can. Aim deeper also correct. So aim the fish at a lower positions. Okay? Aim the fish at a lower position. Simple, straightforward. That's it. Okay. Next one. What happened to the depth of the fish image? Now, they want the fish image. Okay, guys. Do you remember we mentioned about depth before? In these chapters, you got two depth, right? You got the real depth thing and then you got apparent depth thing. Recall this? Real depth, apparent depth. Okay. So, depth of the fish image is what? Is it apparent depth or is it real depth? Apparent or real? Apparent or real? Fish imaged. Of course, apparent. Real depth is for real fish. You know what I mean by apparent? Apparent means the fake one. The one that you saw. Apparent, right? So you saw this, so that's your apparent depth. And you know where is apparent depth or not? Apparent depth means from the image of the fish, you go to the water surface. This is called apparent depth. We put a small h here. Real depth, right, is actually the fish, the real one. Then you go to surface. This one called real depth. Real depth, we put capital H. And then one simple thing real depth always deeper, because real depth always is inside one. That's why we put, you know why we put big H? The number is bigger. Small h, number smaller. Okay, there we go. Follow. Okay, now back to this. What happened to the depth of the fish if it's placed in an oil of tank? I'm sorry, a tank of oil. Okay, now where are you originally? The fish, water. Now change to oil. Okay, so what happened to the optical density? If you go to oil, the optical density is higher or lower than oil. Okay, now I write for you. You write down also. Optical density for oil, is it bigger or is it smaller than optical density for water? Okay, now this one, I tell you what, how to tell optical density higher or lower? Very simple one. You know what means by optical density? In simple as this means how your light will travel. Okay, now normally, remember we said many times, right? Okay, think about this. When we go to something denser, the light will go faster or slower? When we go to something denser, slower. Correct. It's like, pasar malam. A lot of people, can you walk across it fast or slow? Slow, right? What means by less dense? You go faster or slower? Less dense. Slower. Less dense, my bad. Faster. Because empty, Okay, actually, you should say optical density. And this optical density is like that one. You want to know higher, lower, very simple. You go to this medium. Okay, if you go into this medium, you can go faster. That means your optical density is lower. If you go into this medium, you go slower one. That means your optical density is higher. You get it? That's why I say the logic very similar to density, right? Now, think about it. Light inside oil, is it going to be faster or slower compared to water? Okay, you know what? Imagine yourself as light. Now you go into a swimming pool. If the swimming pool the whole pool is oil, full with oil, will you swim faster or slower compared to water? Imagine the swimming pool now is made of oil. Will you swim faster or slower compared to oil? Compared to water, my bad. In oil, you swim slower. That means, now later I explain, slower, That means your optical density is higher or lower. Oil. This one, it's the exceptional case. Because now, most people tell me, hey, I thought density for oil is lower one. That's why. Optical density, yes, most of the time, right, they follow density. But then there are exceptional cases. So, of course, you say, then do I need to remember everything? No. Usually, they ask you the common liquid like, water, oil. These are typical ones. So, you want to know the answer also very simple. Think about it yourself. If you are light, you swim faster or slower. If you are in this medium, you go slower, means optical density higher. If you are in this medium, you swim faster, means optical density lower. Get it? Now, inside oil, you swim slower. Why? Okay, you try to think about the texture of oil. The texture of oil, how? Like full thing oil. Normally, oil, right, the stickiness, higher, right, thick one, higher viscosity, right? So, with such high viscosity, will you go faster or slower? You need to like push through, like all the way through. So, are you going faster or slower? Water got sticky or not? Water you just go over, right? But then inside oil, you have to scoop yourself over, right? That's a simple idea. You can imagine, like, okay, of course, you know what? You don't imagine like your mother's sunflower seed oil, those cooking olive oil. No. Even those, you think about it, you try to later you go to your kitchen and try, you pour a bit out, you see how it flows. You compare, you have a bottle of water, you pour, go very fast one, right? You pour the oil out, does it come out as fast as water? No, right? They flow kind of slower compared to water, right? So optical density for oil actually is more than optical density for water one. In a way also because of the particle bonding. That one chemistry already. I try not to push it. Try not to link to chemistry but the bonding between oil is stronger. So it's harder for you to go through actually. So this one, that's why I want you to understand exceptional case. Optical density for oil actually more than water one. Yes. Now, one more. Optical density more, right? What happened? I ask one more thing. If your optical density is higher, okay, if your optical density is higher, can you tell me the refractive index for oil, how? Is it higher or lower compared to water? The refractive index for oil, it will also be higher. Yes, together one. Optical density and refractive index, same. Okay, if your optical density higher, then your refractive index also higher. Together one. I give you a simple example, then you can see the relationship. Now, let's say refractive index for water is 1.33. Here got give, right? Refractive index for air is 1.0. Which one the optical density is higher? Optical density for water or oil, you can guess. You swim. Imagine you go through water or go through air, faster for you. You see or not? This one more dense, right? Harder to go through. Now, density higher. Density higher. Density lower. Then you look at the refractive index. Water higher than air, right? So they link together one. When your optical density is higher, your refractive index also higher. Conclusions. Okay? Now, so back to this. Since you say the optical density for oil is higher than water, right? So what is going to happen to the depth of the fish? Refractive index higher, correct. Then what happened to the depth of the fish? Is it going to increase or decrease? Okay, how about simple maths lah? Guys, how about simple maths? N equals to real depth over apparent depth. Okay? Real depth is the same. The real fish never change one. It's changing the apparent depth. Now they're asking you what? They want the depth of the image. They want image, that's why H. Okay? Now, you go to oil, refractive index increase because the optical density higher. What happened to this? Simple mathematics. If your N goes up, what happened to H? Increase or decrease? We say this many times, every time. Hold on. Okay, I'm back, sorry. So, what's the answer? What's the answer? This one go up. This one decrease. Correct. Answer. So what's the answer for the depth of the image of the fish? It will decrease. Okay. Anyone? Questions? Good. Okay, explain the answer. I think we got answer already, right? What's the answer? Simple. Yeah. Why the H will decrease? Because the N increase, right? And how come the N increase? Why the N increase? You give them the ultimate answers, because the optical density of oil is higher than the optical density of water. Again, this one different than the usual situation, because why? Normally, yes, if you say density, actually oil lower, right? Your oil floats in water, but the problem is optical density for oil is higher because it's harder for your light to go through. Imagine yourself as a light, you swim through harder, right? There you go. Okay, next one. Calculate the depth of fish image. What are we calculating? They want the depth of fish image, meaning what? Apparent or real depth? Apparent depth, correct? So N equals to real depth over apparent. Okay, I teach you one more trick as well. You know, you got all kind of different refractive index formula, right? In the formulation I give you, altogether got 4, right? Now, one simple thing that you can always double check in exam, right, is that you have to make sure this thing, the value for N, they are always more than 1. Or more than, sorry, frozen, my bad. Okay? Now, the value for N is always more than or equals to 1. If you get answer less than 1, something is wrong. Okay? There you go. Okay? Substitute inside, we get answers. N is given, only memorize 1.33. Real depth of the fish, how much is it? Real depth of the fish, it's here given. They tell you, right? 0.5 meter, so put inside, right? So 0.5 meter, and H equals to how much? Come guys, I need my answer, please. You calculate for me. You bring the 0.5 over and divide. Answer, please. What do we get for this? 0.5 divided by 1.33. 3 decimal point. 3 decimal point. 3 decimal point, quite fine, really. Quite enough. You get 0.3759, right? Then I put 6. Normally, for calculations, I would suggest 3 decimal point. If it's endless decimal point, you want to put 2 also can. 4 also can, depends. If your teacher say, oh, I want 4, then you put 4. Normally, 3 is quite sufficient already. Okay? Okay. Any questions so far? Can I continue one more? All right, let's finish up this picture. We calculate the critical angle. Come, formula for critical angle, 1 over sine C. You want to look for this one, C. So N is 1.33 still, equals to 1 divided by sine C. So if you want to calculate C, what do? Put everything over, throw over. So C equals to sine inverse 1 over 1.33. Guys, calculate this. How much do we get? Angle, normally 2 decimal point is already enough. Angle, no need to put so many decimal point. You can't measure them anyway. Right? How much? What's the angle? Sine inverse. Hey, I want more people give me answer. Hello. Then I know whether you are following or not, right? If not, I don't know whether I should go on or not. Okay? Yes, respond. Where are you? Did you get this? Everybody? Found it? Put bracket. Sometimes your calculator very dumb one. They don't know what you want. All good, everybody? Okay? Next. Okay, questions regarding this page? Okay, this one. Diagram 9.2 shows a diver is swimming underwater. While swimming, he could see a bird flying above the water, a fish swimming behind a big rock. With an edit of diagram, show how the diver able to see the image of the fish and the bird. Okay, now you are here. The fish is over here. The bird is over here. How do we draw this? Okay, first of all, to be able to see the bird is not a big problem because while you look up, you see it, right? But of course, you can't just look up because why? Notice, right? This is water, outside is air. Definitely got bending one. Okay? Now, my question is, what happened here? How do you see the fish? You notice a problem? You know what's the problem for this? Can you look straight and see the fish? The rock is blocking you, right? So what is the only way that you can use? What is the only method we can use to actually saw the fish? No, refraction cannot do this. Refraction don't bend down. Refraction either bend towards or bend away. They don't do this, you understand? Unless, what is it? Obviously, right? Now you have to use not to use what tools lah. What phenomenon are we doing? Simple, I telling the answers already. This is the total internal reflections. Guys, remember to spell correctly. Reflections. Total internal reflections. Refraction, not same. Reflections. Okay. Now, so for the fish, what is the phenomenon involved? Yep, total internal reflections. Okay. Now, some of you say, hey, how is it possible? I thought the water transparent one, right? I give you a simple example. In real life, it does happen. Like, for example, you look at this thing. You can see, right? This one is the actual fish. But you notice what happened to the up here? Do you realize, right? Here is like a piece. It's now, around here, it's like a mirror now. Instead of seeing through, by right outside is sky, right? What do you see now? Do you notice they reflect the bottom? You see the fish of it, and then you see all these rocks under at the seabed, all the whatever rocks coral stuff, right? Okay, one more thing. You look at the image produced. You look at your fish. What do you notice? Can you tell me what's the difference between them? Straightforward answers lah. What do you notice? Do you realize? Yes, reflected somehow. One thing. Look at the image and look at the fish. What do you notice? Beside distorted, one thing. The most important part, they are inverted. Realize the fin here and then suddenly become the terbalik already. Inverted, correct. So this one, right, it's inverted. Then when you draw that time, remember, because it's like mirror. You think about it, when you look into mirror, everything terbalik one, right? Left hand side become right hand side, up they become down, left become right? They are always inverted. Okay, so that's why for this, how do we draw this? Okay, now, normally, there's two ways to draw it. Number one, you start by drawing the light ray from the fish and then bounce back to the diver. Is it a problem? No, but normally make problems. Usually you make mistake one. I teach you another trick. Okay? Not to say cheating, but dummy proof, confirm correct one. Because one thing also, when we draw reflections, the angle must be how? If you draw reflections, total internal reflection, just now we mentioned, right? Your incident angle and the reflected angle must be how? Same, right? Because it's like mirror, you go and measure angle here, right? How would you know? For example, if I draw like this, are you sure the angle is the same here? You can't tell, right? And if you're gonna use projector measure, waste of time. Now I teach you a way. You reverse the drawing methods. Nobody knows, right? Your teacher not gonna know which one you draw first, right? But this method, dummy proof, not gonna lose mark one. So what you do, very simple. Okay, first you draw the image first. Instead of drawing the light, draw the image first, because you already know where is it. So think about it. Imagine this is like a mirror. So where's the image of the fish? The mirror, everything same one. Angle same, distance same. Just that you have to draw it reverse, terbalik, right? Now what you need to do, very simple. This one don't copy. Look here first. I give you time, draw later. Now you measure using a ruler. Agak-agak lah. This one. Then what you do, right? Simple. You just measure the same distance out of the water surface. That is where the head of the fish. Same thing also. You go to the tail. You measure the distance here, and then after that, you measure the same distance, you put it outside the water. That means the fish will be around here, the image. Now, but the problem is you have to draw terbalik, right? Now, relax. This is physics, not art class. So you're not required to say, oh, I need to draw such a beautiful fish one. What about the bird? You need to draw one feather by one feather. Don't be crazy. It won't be like this one. So what you do, very simple. Okay, I teach you a trick. Now you're holding paper, right? You terbalik the paper. You reverse the paper, reverse this way. After that, right, you see what I do? I draw accordingly. So this is my fish. Imagine just draw a normal fish, like that, the usual fish that you can draw, and then put the eye here will do. Okay, don't forget the fin. Now you see, if I turn it back, it's a reverse fish already, right? Now it's like a reverse fish already, right? Don't worry, physics they don't care about drawing ugly one, as long as you deliver as long as you can tell them it's a reverse fish. Normally in real life, your exam questions, they won't be so difficult one. They will just draw a simple fish shape. Okay, Once you've done this, erase off everything. Look here first. You trust me, you listen first, okay? So that's the image. Okay, so first thing first, what do you do? Now I ask you a question. Diver saw the fish or the real fish? Diver saw the fish or the real fish? I mean, sorry, the image or the real fish? Which one did you saw? You saw the image, right? So what you do, very simple. From the eye of diver, you draw one line to the head of the fish. You draw another line to the head, to the tail of the fish. Now, of course, you know what? The light are being reflected from the fish, right? So over here, what happened? You just bounce it back. Now, this line supposedly just now go to the head, right? You aim back to the head, can already, no? See that? Now, you see this line just now? Over here, this line here, you go to the tail, right? Then you aim back to the tail. Understand what I mean? After that, look. That's why I say don't copy. Erase off this one. Now, don't erase off everything. You make it dotted. There you go. And then you see when I do like that, what's the good thing about it? Number one, I don't need to measure angle, but you look at it. Do you realize the angle is exactly same one? That's why I say this way, dummy proof. Don't need measure angle one. You just draw like that, everything will come out. Now, finally, you need to label what? Directions of the light. Where does the light come from? Just now we said, right? Where does the light come from? From the fish to the diver. There you go. Now, guys, 3 steps. Listen, I give you time copy later. You listen first. Especially drawing like that, you need to understand. If you copy, you don't listen, right? Then later, I will get a question from you asking me the same thing. I know what. The moment you ask me why like this, I know. You are not listening, you just copy and then you shut down yourself. So let me finish first. I give you time draw later, okay? Now, so how to do this? Step 1, draw the image out first. Now, the best, label it, of course. Okay? Step 2, draw 2 lines to the eyeball. Okay? To the diver. Step 3, draw the light back from the fish. So always like that. Draw this one first and then pew, 2 lines. After that, bounce back to the same place. Erase off all here, answer come out. Exam like that, 3 marks for these questions. Okay, don't forget your directions. Light go from the fish to the diver. Understand? Okay, now this one, any problem? Everybody good? If you're okay, right, can you send me a fish sign like this? Don't copy first. I want to do the bird together. Then you draw one shot. But I'm asking you, this one can understand. Okay, 3 steps. Draw image, light to the eyeball, bounce back to the fish. Works every time. Now, same thing for the bird as well. Draw image, light ray to the eyeball, reflect to the real bird. Okay, now, look here. First, this one also, pay attention. Pay attention. Don't draw this one first. Now, you look at the bird. What is the phenomenon happening here? What is the phenomenon happening here? If you look at the bird, right, are you going to have total internal? No need, right? Just refraction, correct? Okay, refraction, refractions. Now, one question: the image of the bird, is it going to be closer or further? Where will be the image? Closer or further? Think. Closer or further? Okay. You know why I want to do this question or not? It's a very different one. You know why? Okay, just now you answer. This one, is it closer or further away from the water surface? This one, right? You notice your image is closer to the water surface compared to real fish. But you know what's the difference? Where are you? This diagram, where are you? In the air. Agree. And then you look into the water. Okay? Now, where are you? Water. And then you look to the air. Now, why I do this? Because these questions, right? The logic, the balik one. Now, look again. I explain again. If you are, let's say your eyeball is in the air, you look into the water. The light is traveling from denser to less dense, right? Then they bend away. That's why the fish will look shallower, as in closer. Okay? If your eye is from air, and then the fish is water, now they go closer, right? But you notice now what happened or not? Everything reversed. You are in the water, you go to air now. You get what I mean? So now the logic terbalik means what? If you reverse it means what? Correct. Instead of getting closer, it makes it go further now. So now where is your bird? Now simple, I got sketch the shape. Okay? Again, exam not gonna ask you draw the actual eagle one. This one crazy. All the feather have to draw, man, right? No need lah. You just draw agak shape can already lah. Now this is the bird, right? Now you're supposed to have the image further. No, in front, behind, no need. You just here. If you say closer, you draw here. If you say further, you draw here. You get what I mean? So because this one, the logic reverse. Why reverse? Just now you are at the your human is in the air, right? Now the human is in the water. That's why the reverse one. Now same thing. Once you got to this, same thing. What do we do? 3 steps. What's the first thing we do? Draw the image out. Done. Second step, what do? Two light ray from the imaged. You go to the eyeball like this. Okay. And then number 3, what do? There shouldn't be a straight line here, what, right? The light ray is supposed to bend, right? There you go. Aim back to the real object. After that, erase off the image line. Make it dotted. Notice or not, the way we draw is the same for both. The way we draw is the same for both, right? There you go. But then you need to understand what is happening. Okay, every time 3 steps. Imaged, draw first, and then lights to the eyeball, bend back to the object. Don't forget the directions of light, very important. From the real bird to the diver. Understand? So that's the thing. Same thing here. Image 1, light ray 2 to the diver, and then finally bend the light back to the bird. Any questions regarding this? No, this one, why need to terbalik? This one got no reflection also. Yeah, it's just refractions. The orientation same one. Why do you reverse the bird? No need. That one is because it's like for the fish, right? Because you're using reflections, that's why they reverse. But for the bird, right? No, they're just like this. Understand? Okay, now you can draw. Now you try drawing yourself. 3 steps, Image come out first. Object, then you draw the light ray to the eyeball, and then bend the light back to the object. Oh yes. Every time, need normal line. Normal line is 90 degree. Normal line is 90 degree. Every time, need normal line. Okay, there you go. Got it? Okay, now come. Draw yourself. I give you some time. Once you're done drawing already, you send me an eagle like this. I go toilet. Okay, I think I see a lot of you sending me. You don't? Will come out Amali. Amali, yeah, I posted the I posted what? The Amali forward file. From 5 midterm, normally the teacher prefer to come out from 5 chapter lah. And then the cheapest way of doing Amali is that they use existing material. Last year SPM, they come out with buoyant force, so they should have quite some. They should have quite some of the material left over. So your teacher might consider coming out that one. But from 5 chapter 1 and 2 spring buoyant force water pressure these are the typical one that they like to come out for midterm. Can we go on, someone? Real object closer? What do you mean by closer? Oh, for refractions, if you go from denser to less dense, you bend away. So when they start to bend away, later I'll show you this diagram again. But are you done for this drawings? Everybody? Done, right? Okay. Now, this one you see the light from the fish is from here, right? But then the thing is, when you go from denser to less dense, now supposedly light travel straight, now they bend away, right? So when they bend away, less dense, bend away, you look straight, the image will appear here. That's why they look shallower. So if you are here, your eyeball is in the air, your object is in water, then they will look closer. Meaning your light travel from denser to less dense, they look closer one. But then now, right, the light is from outside, like here, air less dense to denser. Then the logic will reverse. Okay, denser to less dense, this one, denser to less dense, they look closer. That means less to denser, they look further away. So that's why this one, up here, further from your eyeball. Move on. Number 2. Now this one is another example that very typical to come out. A lot of time when we do this total internal reflections, this question a lot of people tend to skip, but it's not that hard anyway. Diagram 1.1 shows a car driver on a hot sunny day. That's your keyword. Okay, image of the cloud can be seen on the road surface as in here. Now, this image means it's not real, right? But the image disappeared when they approached. Now, have you seen this before? Actually, in real life happens quite often, especially when you're driving. Let's say next time you go back hometown, whatever, your father driving on a highway, like empty, surrounding or no building, no blocking one. It happens all the time and must be on a hot day. You know why or not? Because let me ask you a question. On a hot day means what? The sun is hot, right? Okay. Now, when the sun shines down, which part heats up first? What's the first thing that gets heats up when in the daytime? The hot sun. They don't heat up the air first. They don't heat up the air first. They heat up what? They heat up the land first. You know why they heat up land first? Reason very simple. The ground, it's made of solid, right? Now, why the land heat up first? Because the specific heat capacity, is it higher or is it lower? For the land, is it higher or lower? Yes, for the land, it's actually lower specific capacity. Heat capacity lower means what? They heat up faster, they cool down faster. Heat capacity higher means what? They cool down faster, they heat up also slower. Sorry, they cool down slower, they heat up also slower. Okay, so first thing first, hot day, land heat up. Of course, when your land heat up, what happens next? The air nearer to the land, right? Of course, is hotter lah. That's why you can see here label for you, right? Sometimes you don't label, you need to know yourself. If your land is hot, the air nearer to them is hot. If your land is cold, the air nearer to the land is cold. Okay, now we got two different regions here. Now you got all this line, actually not important one. You can just imagine you got two regions up here, down here. Okay, now density, obviously different, right? Hot air, cold air. Where do you get higher density? Where do you get lower density? Hot air, is it denser or less dense? Hot air. Hot air. If you don't remember, very simple one. Hot air. Balloon. Okay, balloon. You got hot air balloon or you got cold air balloon. You got hot air balloon or you got cold air balloon. Hot air balloon. And then what happened to the hot air balloon? Does it go up or does it go down? Hot air balloon. It rises up, right? How come? Because the hot air balloon, the hot air inside, they are less dense. They are lighter in a way. So that's why actually here, hot air is less dense. And then your cold air is denser. Follow? Okay. Now, it says this is the image of the cloud. Where do you think the cloud is? The real cloud. Where the cloud will be? Do you have cloud on the floor or not on? No, right? So where's the real cloud? It should be on the sky here, right? There you go. So you see, I gotta draw first, later you draw. Okay. Now this is the cloud. So what is happening? Again, why do you see the image? Because the light from the cloud, they come down. And then look, guys, look here. Now, when the light from the cloud come down, you notice what happened or not? Where they are traveling? They are traveling from top to the bottom, right? Meaning, we are going from cold air to hot air, agree? Okay, first thing first. Cold air, denser. Hot air, less dense. What happened? When the light travel from denser to less dense, what is it going to happen? Denser to less dense. Do we bend towards or bend away? Denser to less dense. Or I should be more exact. When we go to something denser, are we bending away or towards? Now, less dense, we go faster. Denser, slower. Faster, where do we bend? Now, these are the things that you have to remember. You tell me, oh, I don't remember, all right. Then you have to. These are the things that no choice one, you have to remember one. Okay? When you get faster, you tend to bend away from the normal line. You get slower, you bend towards the normal line. So here, now, this part, no, not yet total internal. Because why? Now, of course you say, hey, I thought denser to less dense, we get total internal. No lah. What was the condition again? In order to have total internal reflections, you got two conditions, What was the conditions we have? Number one, yes, we go from denser to less dense. It does fulfill. What is the second conditions? What is the second conditions? Guys, the incident angle need to be more than critical, right? Now of course, this one, you say, and how do we know whether more or less? The reason why they got this thing is because total internal, right? Of course, you don't know this, you also don't know this, but the thing is what? At first, you can see, starting, right, the angle smaller, right? This is the eye we're referring to. So here, not yet. Your eye not big enough. But then the problem is, when you go from cold to hot air, you bend away. Bend away means what? Your light rays start doing this. Pew. See that? Bend away, right? Okay, now you see again what is happening here. Do you realize now your angle is bigger now? You compare here. Do you realize the incident angle become more already compared to this one? This one larger, right? When you got larger angle, once the incident bigger than critical, then notice what happened. Your light ray supposedly should keep bending away, right? Instead of bend away, now you have total internal. So actually this one, right? Exam, a lot of people don't know one. They straight away mentions, the light travel from cold to hot air, denser to less dense, and the angle bigger than C. That's why total internal. That's why they see the cloud. Like that, you don't get full marks one. Because normally we don't have total internal start first. At first, what is happening here? Okay, now you tell me what is happening here? What do you call these conditions at this point? Are we having total internal yet? Nope. This one is only bending away. Meaning what? Only refractions. Okay? Now, only when it comes to here, right, then you get total internal. Okay, why? How come at this point you get total internal already? Because at this point your angle big enough. Understand? So that's the whole process here. The light from the cloud travel from cold to hot air. They will start to bend away. Now, as they bend away, they cause the incident angle to increase. Once the incident angle greater than critical angle, total internal reflections, the light reflected to the eye of the driver, and the image of the cloud will appear on the ground. Understand? So first thing first, can you tell me what is the phenomenon that occurs in the diagram above? No, this one I'm not asking for the for total internal. What do you call this? This phenomenon, that you can see the cloud from the sky on the ground. We have a name for it. Yes, the thing is actually called Mirage. A lot of people actually don't realize this, right? And some people tend to overlook lah, Mirage. How does thing happen? Simple, okay? First thing first, what do we say? No, before you tell them the light whatsoever, what's the first thing we say? Okay, on the hot day, what happened? The air nearer to the ground is hotter to the air above. Okay, now you want to keep saying that, you want to say that because the land has lower specific capacity, you can say that as well, right? But actually this one is not about chapter heat lah. That's why I can just go through quickly. Just mentions that hot day, air nearer to the ground, hotter than air above. Why is it like that? Because the land hot, so the air nearer hot. Next thing, what's the second thing we say? Near air hotter, then what? Hot air, cold air, what's the difference? Hot air, cold air, what's the difference? Hot air, yes, density, correct? Hot air how? Is less dense compared to the cold air above. The cold air above. Hot air nearer to the ground is less dense compared to the cold air above. Second, settle. Third, then we say the light travel from the cloud, okay, from cold air, okay, from cold air, denser cold air, to less dense hot air. The light will do what? If we go from denser to less dense, we bend, correct. Where do we bend? Bend away from the normal. Okay? Then finally, as the incident angle increases, it will eventually be greater than critical angle. It will greater than critical angle, and total internal reflections will occur. This causes the light of the cloud to be reflected to the eye of driver, and that is how you'll be able to see the cloud on the floor. Okay, so first thing you mentions that the air nearer to the ground, okay, air nearer to the ground, hotter. Then hot air is less dense. After that, travel from denser to less dense, you bend away. When you bend away, angle increases. Or you can mention here lah. You can add on some more actually. The light will bend away from the normal, causing the incident angle to increase. So when your angle increase, eventually greater than critical angle, total internal reflection occurs. Mirage questions? Understand now? A lot of people saw this phenomenon that you give already. You say, I cannot understand what the textbook says. That's what happened. And then they also ask you to complete diagram above. So that's what you're supposed to draw lah. The cloud you draw nicely a bit lah, but again your teacher don't catch this one agak lah. So cloud. Okay, it's okay. Physics, not art. They're not gonna say, hey, you're drawing ugly, no marks. As long as you show whatever you're supposed to show. Light here, bend away, and then total internal. Okay. Let me know when you're done. You give me a clock. Oh, like that. Total internal reflections. Total internal reflections. This one. Total internal reflections. So TIR. Short forms. Every time I write very long. This I feel like, it takes a lot of time, so I just do short form. But exam, please don't write short form. Yes, please write everything. Okay. Alright, I think we can go on. The drawing done already. Move on. We try an essay. Then I can move on to lens as well. If I got time, I do mirror, but I think lens are gonna consume quite a lot of time because you're gonna be very blur about it. So I mentioned about, but please the question inside, go and do. It will help a lot. Even if you don't know how to do, right, there's an answer for you. You can check answers. But yep, it will help you a lot for your exam. I cannot guarantee exactly will come out for exam, but you will definitely benefit from this. Can we go on to the next one? Not yet. Okay, wait. Alright, I'll wait for you. Okay, move on. Next one. Okay, here. Endoscope used by doctor to examine it. You know what's an endoscope? The name tells you the answers. Endoscope. Endoscope. Endo means inside. Scope is like scope, right? You know, science, you learn about exoskeleton and endoskeleton. The meaning of endo means inside. So this thing is, the doctor used to examine your internal organ. That's why it's called endoscope. Can use to see all the things. Any body, your body got hole can put inside. Your mouth, your nose, your ear, your stomach, your intestine, all can. Now, inside endoscope uses this thing called optic fiber. This is the applications of optic fiber. Yep. You know how optic fiber works? First of all, optic fiber it's a transparent material. Okay, but then special thing about this optic fiber, it has two different layers like this. Okay, special thing about this optic fiber, got one layer, it got one layer. Okay, got two layers. Now one layer inside, and then you got another layer that is outside like this. Okay, now so inside, never mind. So that means if you look at it from in front, they'd be like this. You got two layers. Okay, one layer outside, one layer inside, this way. Okay, so here, this is the inside layer, as in here. Okay, then this one is the outside layer, here. Okay, and then we have name for it, the inside layer. You know what do you call it? The red color part. This one we call it inside, right? So we call it inner core. Okay, then the outside layer, this one, both outside, this is called the outer. Where got outer core? Core means center, right? It's called outer cladding. One thing very important that you need to know is the material choice. Sure, they ask one. They will ask you to decide what material is supposed to do. Now, exactly what material? No. They will ask you to decide, should you do high density or low density? Okay, now, simple. Your light ray will be entering from here. Okay, from one end, they will be having this total internal reflection, total internal reflections. They bounce all the way, they come out from the other side. Okay, but here's the problem. As I mentioned, right, this thing is transparent, right? It's transparent. So, what is the only way to actually make this happen? How come the light ray bounce inside? How come the light ray keep bouncing like that? What is the phenomenon that happens? Obviously, when we say optic fiber, all this, what's happening? There we go. Total internal reflections. And again, let me ask you a question. Can you tell me, right, where should you have higher density? The inside or the outside, the density should be higher. Inside, outside, the density higher. What's the condition for total internal reflection again? What was the condition again? Inside? No. The condition for total internal. They must go from, yes, angle more than C. Some more, one thing. Before we talk about angle, what's the first thing first? You want total internal reflections, you must go from denser to less dense. Correct. So, you see or not? Your light ray is here, trying to go outside, right? So, inside must be denser or less dense so that they don't go out. They will bounce back like that. There you go. So, inside should be denser, outside should be less dense. Then only you get denser to less dense, right? Total internal. Get it? Okay, one more thing. Guys, if I have a higher density, meaning what? The refractive index also high or low. If your density is higher, what happened to N? Higher, lower? Higher, correct. Refractive index, higher, lower here. This one, lower. Follow together one. Remember just now I showed you, right? For example, the example for water, the water concept, you see, density is, okay, refractive index for water is 1.3. Refractive index for air is 1.0. But do you notice one thing? Okay, the density for water is higher, density for air is lower, right? So when you're denser, usually you got higher refractive index. When you're less dense, you have lower refractive index. Good. Okay, back to this. So over here, there you go. Can follow? Can I move on? Okay. All right. Now come choose. We need to find one most suitable one. Okay. First thing, got answer already, right? What's the answer for first one? The refractive index of inner core and outer core. Which one has to be higher again? Refractive index. Nah. Inside denser means inside refractive index higher, right? Then outer must be lower. So what's the answer? Which one do you choose? Now NO means outer lah, and I means inner law, right? So O means outer, I means inner. So which one do we choose? NO need to be smaller than NI. So that total internal reflection occurs. Now, little value explanations. So that total internal reflection occurs. Because if you do this, no, you don't even need to say occurs easier or whatever. So that total internal reflection occurs. Because if you do outside more than inside, you're not going to even have total internal, you understand? You're not going to even have total internal. You get what I mean, right? That's the trick. Okay? Now, what about flexibility? Flexibility. 3 marks. What do you think? Should you have high or low flexibility? Should you be flexible or not? You think about it. This thing is going to go inside you. Let's say I put inside your stomach. It needs to go through your mouth, through your throat, all the way down. Should it be flexible or not? Of course, flexible. Low flexibility, you know what happened or not? It's okay. Low flexibility means it's hard. Cannot bend one. Then the doctor gonna stuff all the way in. They're gonna injure your throat and then all the way down, right? Next one, material of the outer. What material do we use for outside? Rubber, plastic, leather, iron. Okay, this material need to consider one simple thing. You see, where do you put the endoscope? Where do you put the endoscope? Inside. Let's say you put it in your stomach. What's the problem? When you put it in the stomach, what's inside the stomach? There are some things that you'd be concerned with. Your food. Hey, hello. Not food Beside food, what else inside? Yes, acid. Right. So, when you put inside, what happens? You have to make sure the acid is not gonna digest your optic fiber, right? So what material is safer in a way? Can we do iron? Can we do rubber? Bad choice, right? Leather, half lah. But among all, right, which one is the hardest to digest one? Which one is the hardest to digest, hardest to decompose? Plastic. I mean, yes, okay, we cannot guarantee plastic confirm won't digest but when you put inside, come out, the duration is a bit short. They won't react with your plastic one. Before they can react, you take out already. So plastic is safer because they do not react with the acid. Finally, density. Okay, now, did they mention whose density here? Did they mention whose density, inside or outside? Didn't, right? Okay, when they don't say whether inside or outside, what they refer to is overall, the whole thing. The whole thing. Like this whole thing here. So what do you want for the density? Okay, and this thing I think we do many times already, for science. Density, how? Every time we say, right? Whenever for density, how? What does density control? not, you don't care about this lah. Whatever it is lah. Every time you say density, it control the mass, right? It control the weight, right? Correct. So do you want your endoscope to be heavy or light? Do you want your endoscope to be heavy or light? Light means what do we choose? Correct. We choose low density. Because you need to, the doctor need to hold and then slowly put inside. If it's very heavy, how? Very hard to hold, right? Very tiring to hold, right? Then the doctor accidentally suddenly let go, how? Boom, all the way down, fall into your stomach. So it has to be lighter so that easier to control. Portable can, easy to handle also can. And finally, right, answer is X. Got it? So that's what we're supposed to have. So far so good? Can. Okay, now let me show you the answers. You can drop down the point real quick. But then if it doesn't part to copy, please take a screenshot of it. Again, the answer will give one, all right? I say already just now. Okay, I'll post the answer, I'll post the answer, I'll post the answer, okay? If you are my students, it will be in your GC. If you are not my students, right? Well, how you find this seminar, the website there also got. Can? All right. Now, this one. NO more than NI. Why? So that total internal reflection can occur. Flexibility high, easy to twist and turn. Plastic outer cover. Why? Okay, guys, don't write durable. You have to cancel this off. Don't write durable. Say safe to enter body. And you know what's the better thing? One word to say. Remember why do we choose plastic in the first place? They don't react with your acid, right? How do you say that? It doesn't react. How do you say that? It's chemically, okay, chemically inert. Okay, it's chemically inert. Okay, chemically wrong, right? Correct what? Okay. Use this word, low density, lightweight, and then easy to handle. Now, every time you choose correctly, you explain correct, they give you 2 marks, 2 marks, 2 marks. And then finally, choose, and then after that, you know what means by dot, 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 dot? Literally just copy everything again. Because optic fiber X, the inner core is greater than outer core. High flexibility, use plastic, low density. You just copy everything you said just now, they give 1 more mark for you. So these are the typical section B essay. Okay, section B essay, the essay that I call it the decide essay. They give you a table, you choose one. Meaning this thing will normally show up in question 9 or 10. I mean this kind of format, the one choosing one. Okay, come, write down. Unreactive, not straightforward. Write chemically inert better. No, this one normally they put you to sleep on. They put you to sleep on. Yeah, like how do you not? No, they definitely gonna put you to sleep on because if you're awake, you will struggle on Imagine someone stuff a straw size kind of thing all the way into your stomach, means they need to go through your throat, Confirm you're gonna start gagging and then vomit there one. So they will put you to sleep one. Depends. If you say if I look at the nose, I look at the ear, that one is still fine. Depends on which part. Depends on which part. If those parts are like really inside your body, that one they will give you a bit of anesthetic. But must be anesthetic one. Hello. They just put you to sleep. You wake up, oh, no more already. But of course cannot be awake one. Hello. It'll be painful and then you'll struggle Yeah lah. You don't know one. They just put you to sleep. You wake up. They say, okay, done. Are you done for this? Oh, conclusion, you can write the full. You can write like this also, or you can write the full sentence also can. Okay. Yeah. You can write like this, or you can write the full sentence also can. But then I will suggest now write the whole thing now, because now in SPM they are quite lenient, to be honest. You write point form, short sentence, they give you marks one. But I will always suggest students, right, to put full sentence. It's safer in a way. Yeah, I mean, and also it trains you to write a complete answers. In high school, yes, they allow you to do that. But then you think about it, you need to consider, what about in you go to college, uni, huh? You write point form, the lecturer not going to care about you, throw away straight away. In high school, they allow you to do so, but it's a bad habit anyway. You lose the ability to express yourself. Like, you can't even explain yourself. You point form. Cannot do this one. So I will always suggest short sentence, complete sentence. Safer, better in a way. Okay, are we done for this, guys? Can I move on to next one? Okay, can we look at page number 15? Page 15, 1-5. Done, 3, 2, 1. Okay. 15, question 5. Diagram 5.1, 5.2 shows a parallel light rays. Shows how parallel light ray passing through two different types of lens. F is the focal point of the lens. Okay, could you see the shape? Might not be able to see clearly, I draw for you This one here, like this. Okay, what kind of shape is this? And this one here, like this. What kind of shape is this? What do you call this? Again, sorry. What do you call these lens? This one, 5.1 is con. This one is convex, correct. Convex lens is what lens? Convex lens is what? I mean, you look at the light ray, what does it do? You see? They focus all the light to one point, right? So what do you call this convex lens thing? Yes, if it's a convex lens, then we call it as if it's convex lens, we call it as converging lens. Okay, convex lens, we call it as a converging lens. Following? Okay, now what about this one here? Obviously, what shape will we have? No, I'm asking for shape first. Shape. This is concave lens. And what does it do? Concave lens. It actually causes your light ray to diverge, right? To separate, right? There you go. Can follow, Concave means concave. What do you mean by concaving lens? No concaving one. Concave, convex, concave lens, convex lens. That's it. No need to put ing on. Converging, diverging. Okay, diverge means they separate the light. Converge means they focus. Okay. Now, why do I want to do these questions, right? Got one thing here very special is that, number one, you see what they do or not? They ask you to compare. Now, you try to recall your paper 2, form 4. Always, right, there's this few questions. There's always these 2 questions ask you to do this, like all the comparing thing, right? Now, usually compare very easy one, right? You just compare which one bigger, which one smaller. That's it, right? Now, when we say compare, right, you got 4 answers: bigger, bigger, lesser, and then equal. These are the usual one we have. They compare which one bigger size, which one can travel further, which one the mass is bigger, those kind, right? Now, if really cannot compare, then you go to the 4th answer. Because why? They ask you to compare the type of lens used. Over here, how do you compare the lens here? You see the problem, right? What is different between them? Is there anything you can compare? Like you tell me, this one come out more, the surface, this one go inside more. Weird, right? Now, if you cannot compare, then how do you answer a question like that? Simple. You just write what you see. Well, actually, the concept behind, the skill tested behind these comparing questions, right? It's observations. Yes, you just tell what you see. Right, how do you know that one bigger? How do you know this one smaller? Observations, right? Same thing here. So whenever you come across questions where you cannot compare one, okay, you cannot find like similarity between them. You cannot say, oh, this one is bigger, this one is smaller, this one is thicker, this one is thinner. If you can't do that, then just compare, just write whatever you see. So you can just tell them straight away lah. The lens used in diagram 5.1 is what? The lens used in diagram 5.1, used in diagram 5.1 is convex lens, and the lens used in diagram 5.2 is concave lens. That's it. Okay, straightforward answer. Understand? So whenever you cannot compare, just write your observations. Next one, compare how the parallel light ray propagates after passing through. This one also cannot compare, right? Then what do you say? Come, you try. What do you say? This one and this one. How do you cannot compare ma? Then what do we say? You say the light ray doing this and this. You see the light ray doing this and this, right? So 5.1, what happened to the light ray? The parallel rays of light converged after passing through the lens in diagram 5.1. The parallel rays of light diverged after passing through the lens in diagram 5.2. Got it? So every time cannot compare observations. Next one, compare the positions of the focal point of the lens. Okay, now look at this, comparing focal point, how we compare this. Focal point, one is here, one is here. How do you compare? This one also need to state the right statement, right? What can you say? Yes, you can do left and right. You can say the focal point on the right side, left side can also. But actually, if you say left and right, not accurate. You know what's the thing we normally compare with? We compare with this, the incident ray. Now, convex, the focal point, and the incident ray, what happened? Notice they are on the opposite side, right? And then for concave, the light ray and your focal point is on the same side, right? So you can use the same side opposite. It will be easier because now your light ray, must it come from left hand side or not? No, right? If your light ray come from right hand side, then your focal point is here already. So it's more towards where your light coming from, right? If your light is from the left side, focal point the right side. If your light is from the right side, if let's say light coming from here, then your focal point will end up becoming here. What? You understand what I mean, right? So it's better to compare it with your incident light ray. It's more accurate. So that's why for this one here, position of the focal point, how? Okay, the focal point of the lens is located at the opposite side of the incident ray in diagram 5.1. The focal point of the lens is located at the same side of the incident ray in diagram 5.2. Okay? So this one, why I want to do, because this question is special a bit. They are not like the usual one we have. Okay? So far so good? Everything? Okay, now I teach you another trick. Remember the characteristic thing? You know, normally for lens, they ask you about this characteristics thing. Ask you to state for characteristics. Like, you know, the image, is it real, virtual, that kind? Okay, now, here's the thing. You got a few ways to do it. Okay, first, you can always draw the whole thing out, look at the arrow, and you will see. But that one, right, if you're doing objective, waste of time. Is there a faster way? Of course there is. And no need memorize one. I teach you a simple trick. It can help you to remember all the location and stuff. Okay, but for meanwhile, are you done for this answer here? Can? Move on. Okay, now, this one I leave it to you. Conclusion, you just put together whatever we said just now, I put together only. Okay, now in diagram 5.3 here, it shows the cinema. Okay, projector, show you this screen. 5.1, 5.2, which lens suitable to use in the projector? Okay, first of all, can you tell me, right, what kind of image are we having here? Is this a real image or virtual image? Which I make it very obvious to you already. Is this a real image or virtual image? You see or not? Where does the image come from? From the projector. I can literally shoot it and then point to the screen. It forms that one. What image is this? Projector. What do you think? It projects it out, right? So image that can be projected. What do we call it? Yes, that's a real image. Good. That's a real image, right? Okay, then what kind of lens do we use for this projector? Do we do convex or concave? The only lens that produces real image is convex. The only lens that produces real image is convex. Concave cannot produce real image, right? That's why you see, if you could remember the characteristics, things become simple. Am I right? Okay, so which lens is suitable to be used in projector? Answer very simple. This one here, convex lens. Okay, state the reason of our answer. Why do we use convex lens? Okay, because convex lens how? Will produce a real image that can be projected onto the screen. Okay, only convex lens can have real image one. Okay, now what kind of image characteristics do we have here? First thing, simple. Can project means it's real, right? Any other answers? We got three things to compare, right? First thing, real, virtual. Second thing, size. What about size? You look at this thing, does it look like a magnified or diminished to you? Or same size? Always your three answers are magnified, diminished, same size. Obviously, projector, what they do? The image become big or small. The cinema one, big or small? Exactly, magnified, yes. Okay, one more. Is it upright or is it inverted? This is how every time they treat you. The answer is inverted. Guys, look here. You know why or not? Because every time you all misunderstood the meaning of the word upright. When I say upright, you tend to think, hey, isn't this upright? Pointing up, right? Okay, listen guys. Upright means same directions with your object. Does not mean they show whatever you want to see. Okay, you say, hey, isn't this like the correct orientation? Then we call it upright. Then the wrong correct orientation is inverted. Actually, it's not. Inverted means different location, opposite direction with your object. Upright means same, that's it. Okay? Then of course you say, hey, but then this one, how is it inverted? Right, this one I can see the word clearly, right? The reason very simple, because at the projector here, you know what they do or not? They purposely put the object terbalik. Then when project out, they become this. Now, this is inverted. Upright is object like this, your image like this. We call this upright. But here's one simple thing I can teach you. Just remember, these two guys, right? It's a bundle. Whatever lens, whatever mirror, real image and inverted always together one. Virtual and upright always together. Now, since you are very sure that this is a real image, right? Then definitely it will be inverted. But they bind together one. Real image, inverted, combined together. No difference one. And then if it's virtual, it will be upright. Virtual, upright together. Real, inverted together. One package. Okay? Now I show you. Shortcut. How do I remember all these things? Right. Simple. Now, first thing first, I'll teach you a shortcut for the converging first. Now, when I say converging, it's for both person, you know. So what you're learning now, right, is universal answers for both person. So you study 1 equals to 2. So what's the thing you're supposed to know? Now, converging group, we got 2 person. Okay, number 1, you got convex lens. Number 2, you got concave mirror. Okay, now both are converging, meaning that whenever you see a convex lens or maybe concave mirror, you can also use this shortcut here. Whenever you, let's say this is a convex lens, right? This shortcut. If they show you something like this, concave mirror, also can do this. This shortcut works for both. then this shortcut is for you to remember all the characteristics. Now, regardless mirror or lens, you always got 2 point, right? Now, first thing first, whether mirror or lens you're having, always got this guy, right? Which is the F, the so-called focal point, right? Then on the other side, this one a bit different now, right? This one might be different a bit because if it's lens, it'll be like this. Okay, focal point, and then 2F. 2F means twice of F lah. Like for example, if this is 4 cm, right? This is gonna be 8 cm times 2 1. Okay, but then for mirror, we don't call it 2F. We call it center of curvature C. But actually, they are the same thing. I mean same length one. C means 2F, meaning let's say this is 4 cm, this one 8 cm. Understand? Okay, so you got 2 point here, right? Now you can use this 2 point to remember everything. How? First, this one. Okay, we take this as reference point. Now, if your object is located exactly here, if your object is located at 2F or C, like here, exactly here, then your image will turn out to be same size. Okay, meaning if I put my object here, the image will come out same size one. Now, if you put your object here, okay, from anywhere lesser than 2F or C, as in this region here, anywhere 2F or C, this region here, this part, then the image, right, it will be magnified. Okay, and then finally here to here, this part, then this one, right, it will be diminished. Okay, so that's how you remember the size first. From here, same size, magnified, diminished. Settle? Okay, then next we take this focal point as reference point. Now, if your object located here or anywhere less than focal point, as in this region, from at focal point or anything less, then your image, it will definitely be virtual. And if your object is located anywhere more than F, like here, this whole region here, then your image will definitely be real. And then finally, if your image is real, they will bundle one package with inverted. If your image is virtual, they will always bundle one package with upright. Virtual, upright together. If you see something upright, it must be virtual. If you see something virtual, it must be upright together one. Now guys, before you copy, look here first. Can you answer me one question? If I put object here, what image do I get? We try to apply lah. If I put object here, what image do I get? Magnified, real, inverted. See that? Okay, try again. If I put object here, what image do I get? Diminished, real, inverted. So this simple shortcut, everything come out. Now, if I put object here, what image do I get? If I put object here, I get magnified, virtual, and upright. Understand? There you go. Now, what about diverging? Diverging, your life simple. If exam come out diverging, you should be laughing. Why? Because diverging got who? First thing first. Example for diverging. Guys, example for diverging, what do we have? We got concave, lens, and what else we have? We got convex, mirror, right? Okay. Now, this one, no need shortcut. No need shortcut. Because why? No matter where you put your locations, now I put a clear cut here, no matter where you put your object, your answer only got one. Okay, diverging, right? They always, number one, diminish. They will never be bigger. That's why I say, right, the only lens that can give you magnified image, this convex. So how do I know the projector confirm is convex lens? Because of this. Magnified image can only produce by converging lens. Okay, now second thing, it will always be virtual. And finally, virtual packaged with upright. So if you see diminish, answer. No need all shortcut one. Diminish, virtual, upright. One and only one answers for diverging. Converging, right? Follow the shortcut. Okay? So that's a simple trick for you. Of course, write down. Why do you need to draw graph? Why got graph? No, this is just a shortcut to remember. Exam no need to draw this whole thing on. Yes, so because sometimes you need to know what, right? They ask, for example, they put an object here, then what characteristics we have. You need to know lah. Then every time you draw the whole thing out, draw the image just draw the ray diagram just to get the image characteristics right. A bit slow, waste of time. So the faster thing to do is remember this one. And ultimate concept of this thing is based on 2 points only. See? 2F and C is to determine size. Here, same size. Here, anything less than 2F, magnified. Anything more than 2F, diminished. And then you put here, right? Then anything F or less than F, virtual. More than F, real. Real, inverted together. Virtual, upright together. Okay, are we done for this? Can we move on to next one? We good? Next. Can. Now, I show you the drawing. I want to draw both. So, I'm not going to go to the whole question yet. Okay. Now, can you go to page number 12. Number 12, this one. No, the top part, the one I leave to you. I want to do this one. Okay, because I want to make sure you know how to draw your ray diagrams. Now, got two types. The convex lens, the concave lens. Okay, now first of all, this is a magnifying glass, right? Magnifying glass, it's a convex or concave? Magnifying glass. Or I should ask, magnifying glass should use convex or concave? What do you think? For magnifying glass, should you do convex or concave? Smart guess. Oh, sorry. No, what I mean is, you think about it, number one, magnifying glass, you know why is it called magnifying glass? Okay. Now, so, if that is the case, right, what kind of image do you want for magnifying glass? What kind of image do you want? You're looking at a magnifying image, right? Magnified image, right? What lens actually produced magnified image? Just now only I said, right? No? Shortcut here. The only lens that can produce magnified image is what? Convex. Concave lens cannot magnify one. Get it? Okay, next where should I put the object? Okay, first of all, have you played with a magnifying glass before? Have you seen the magnifying glass before? You see through this thing, the object become bigger, right? Okay, try to recall. What do you see here? What do you see here? First of all, the image is magnified, yes? Second, what else do you see? What is the characteristic do you see besides being magnified? Now, the thing you saw here, is it upright or inverted? The image that you see through the magnifying glass. Or you can literally see from this diagram now. Now, this is your original object, right? And then now your image be like this. So is it upright or is it inverted? Same orientations or not? These two. Same, yes? Same or different? Upright or inverted? Same orientation, what do you call it? Upright or inverted? Yes, it's upright, right? Okay. Now if it's upright, that means what do we have? Third point? Upright and what? Together, one bundle always. Stay together. What is it? Upright and virtual, always together. Understood? So there you go. Now, this magnifying glass, whatever you saw is a magnified, virtual, upright image, right or not? Now over here, these questions, right, they want you to, on diagram 3, label the object locations and complete the ray diagram drawing. Now this one special a bit because why? Normally they label the object for you, but now this one they want you to label. Okay, you know why I asked for this or not? Now I want to ask you, where should I put my object? In order for me to have magnified, virtual, and upright. Now first thing, if you want it to magnify, it means what? Where should you put it? Should I put it before or after? Okay, sorry. Should I put it before or after 2F? Before, after. If I want magnified first. Okay, you should put here, right? This region, right? Okay, guys, listen. Listen. This is 2F. This region is called before 2F. Because you measure anything also, right? You start from the lens one. So you see now, this is F and then 2F. This one after 2F. This part is more than 2F. You understand? Okay, this one is less than 2F. Oh, sorry. More than 2F here. This part. And then this one less than 2F. Got it? Okay. So, first of all, if I want magnified image, I must put my object over here. Some more? Where do I get upright virtual? Where do we get a virtual image? You take the F as reference, right? So where do you put it? You should put it around here, right? So which two regions overlap each other? Is this part here, right or not? So that means you need to put your object located here. Understand? Can? No, some people say, hey, actually, put here also magnify virtual, right? What? No. If you put object at F, what's the problem? You know, you will end up having parallel like this. You're not going to see anything. So you're supposed to put here. Okay? Before 2F, before F. Okay, how do we draw this? I give you a simple trick. This one you write down. Every time when you draw a convex lens, remember this drawing method. Number one, right, you go straight and then you go to F. Now, why do we go to F? It's because convex lens is a converging lens. Second, right, you go through the center of the lens. Okay, so two drawing. First, you go straight and then you go to F. Why do we do this? It's because, now, I tell you what, this go to F drawing method, right, this one, it's actually meant for converging. Okay, why do you go to F? Because your convex lens is converging. Now, this one here, we go through the center of lens, right? Now, this one, actually, all the lens do this. Doesn't matter what lens. Whether you are convex lens, concave lens, same. When your light ray go through center, no bending whatsoever. So that's why for this, right, light ray, how to draw? First one, we draw here. We go straight first until the middle of the lens you stop. And then after that, where do we go? Go straight already, where do we go? Go to F, right? Now, here. Now, don't just stop here, go through like that. Okay, just draw through. Okay, now first line, understand? What means by go straight, go to F, right? Second line, what do? Go through the center of the lens, as in here. You see the center here? Straight through like this. Okay, straight through like this. Now, do you have any intersections? We have a problem here, right? No intersection whatsoever. Then how? Simple. Extend. Now, whenever you cannot get intersections, right? Very simple one. You extend your light ray on the other side. Now, what's the point of extending? If they are parallel, when you extend it, you will notice they will never join. You prove it, they are parallel. If they are not parallel, when you extend it, they will eventually intersect and then you get something like this. Do you understand what I mean? And where's your intersections? Over here, drop all the way down. For this point, this is your drawing. Understood? Okay, guys, a few things to pay attention to. Look here, guys. Number one, your light ray come from the head. So the intersect part will be the head. So if your intersect is above, right, you draw all the way down to this horizontal line. That's why they're pointing up. Okay, if your intersect is here, let's say your light ray intersect at the bottom, then you draw like this. You get it? If it's on top, they point up. If it's bottom, they point down. And then you see this dotted line, right? Why? Because the light ray, the intersecting line is dotted, then your image also dotted. If the two line here is solid, then this one also solid. Get it? And now, if we look at diagram, we can also determine the characteristic also, right? What kind of image do we get for this? What kind of image do we get for this? First of all, if you look at the size, could you compare? This image is magnified, right? Now, what does it mean when we get a dotted image. What does it mean when we get dotted line like this? Dotted means what? It means the image is virtual, correct? If you see solid, that's real. Dotted means virtual. And then again, virtual means one package with what? Virtual always packaged with upright. And does it make sense or not? You see, this one pointing up, this one also pointing up. And that matches with what we say here. Okay. Any questions over? Guys, all good? Oh, no. Your image will not be same as mine. Relax. Because this one you don't know exactly how many cm I put. And also you don't know distance for it. We just aga. It's okay. As long as you draw something similar can already. Because a lot of people asking, hey, this one I don't form here how? No, it's normal. It's normal. You will not be same as mine. Because this one, the height different, your image different also. Your location a bit different, it also different. As long as you get something that look like this. Meaning you draw, extend, intersect, dotted, correct. Okay. Let me know when you're done. Let me know when you're done. You can send me a lens. Hey? Magnifying glass got? Don't have. I remember there's a magnifying glass. Don't have. No, never mind. This one. Okay. Next one. Okay. Next one. Can we look at this one? Page number 17. There's another drawing here. Okay, page number 17. In diagram below, there's an object of 1 cm height placed 4 cm away from a concave lens with a power of 25 D. Okay, now this one also we need to draw this. How do we draw concave lens? Now just now, right, for convex lens, to draw it, very simple. We always do like this, right? Go straight, go to F, and then you go through the center of the lens. Okay, go straight, go to F, and then go through the center of the lens. Okay, now the reason you go to F is because of converging. So if it's diverging, right, what will be different? Now look, I'm gonna copy and paste this because I want you to understand the drawing is actually very similar. There's only one thing being different. Okay, now let's say this is my answer. Okay, I erase all this first. This one, take away. Okay, now look, the only thing that changed is the first line. Now, instead of go to F, we go straight and then we go away from F. Get it? So that's the thing here. We got 2 points, right? That's the only thing changes. Now, why do you go away? It's because for concave lens, we are dealing with diverging lens. For concave lens, we are dealing with diverging lens. Okay, go through center, same one. As long as lens all can do this. Light ray goes straight through, no bending whatsoever. Can? But here's the problem. How do you need to go, whether you want to go to F or go away from F. You notice this question here, never label the focal point. Okay, the reason is because they gave this. They want you to calculate yourself. They want you to find it yourself. So how do you get this? Actually, very simple. Right, do you know the formula for power? Lens power, 1 over F. Substitute. Then we get answer. Okay, the power is 25. The power is 25 equals to 1 over F. So if you bring over, F become 1 over 25. How much? How much? 1 over 25. How much do we get? 1 divided by 25, we get 0.04. Now, of course, this one in SI unit, right? So 0.04 means what? It means 4 cm. Okay, that means the focal point is exactly here. Okay, so how do we draw this? They kind of started for you, right? You see, first line, we go straight, right? Okay, now just now, what do we do? For convex lens, we actually go to focal point like this, right? Now we cannot go to focal point anymore. What happened? You need to go away from focal point. And also, you look at the drawing just now, right? You know that your light ray is going to open up, diverging, right? So what you do, very simple. You get a ruler, you aim to the focal point here. Okay, you get a ruler, you aim towards the focal point here. That's what you're supposed to do. This one's second already, my bad. Are you? Okay, but listen, this one, erase off. How come? It's because your light ray never go to here, right? This is only a reference point. This is only a reference point. You get what I mean or not? So actually your light ray like this, go straight and then pew, go away. So how do I know which way do I go? Reason very simple. Because you see, we base on the focal point and then we extend out. That's the meaning of go straight and then go away from F. Because you go straight and then based on focal point, pew, away. Now second line even more simple, straight line all the way, pew, all the way, and then go through the center. Right, now same thing also, don't forget directions, right? Where is the intersections now? Obviously same problem, no intersection here, but do you see intersections over here? Now another problem we have now is that, do you see them? One of the line is solid, one of the line is dotted. Okay, as long as there's one dotted line, then you draw dotted. Understand? One dotted line, then your image will be dotted. Okay, if let's say both lines are solid, then solid. Understand? So that's why here still we are doing dotted, and then where is it facing? Same, right? Because it's above my intersect here, that is supposed to facing up. In our intersection below, then only you draw like this. Above, then they go up. Yep, but remember one thing, what is it? The arrow you draw needs to be dotted, dotted, dotted. Why dotted? Because intersection, one solid, one dotted. Can? And what kind of image we get? Do you realize or not? This image is very small, tiny. This image, right, is diminished. And then dotted means virtual. And then direction is upright. Now that's exactly what we said regarding the shortcut, right? So this is the trick of the idea. Diminish, virtual, upright. That's how we do it. Can? Questions so far? Regarding the drawing? All good? Can? Come, draw this. Let me know when you're done. Okay. here, if you want to see this, if you want to watch this playback again, maybe just now in the middle of the class you blow out whatever lah, you can go to YouTube and then you can find this name. My channel is there, and inside you will also find other videos, such as, for example, remember just now I talked about the telescope microscope thing. You also find video there as well. Okay, so if you want to know how to draw a telescope microscope video, you can go there and find. Everything there already. Inside the channel, you find things, got Mandarin, got English, you find yourself. I will put title there, in front I'll put, if the language is English, I'll put English. Okay? So all this replay, you can refer there also. But so far, all good. Clear. Now, so for lens drawing, simple. Every time, right, got two. Convex lens, okay? If you're doing convex lens, right, then, if you're doing convex lens, then this is your method of drawing. Number one, go straight, go to F. Why? Because converging. And then you go through the centered lens. Lens always go through center, no bending one. Whether what lens are convex, concave, same. The only difference is here. If you're converging, right, you go straight and then you go to focal point. Whereas, if you are dealing with this, for example, here, okay, this one, then we will draw, go away. Because why? Diverging. Converging, go to F. Diverging, go away from F. Lens, go through the center always. Okay? Then you want to remember the characteristics. Simple also. I teach you the trick, right? How do you remember them? There you go. Shortcut for all the converging, then diverging, one and only one answers. Remember, virtual, upright together, real inverted together. Can? And then the one we mentioned just now regarding total internal reflections, I think we are quite clear about this lah. When to have total internal, when to have refractions. You check density being different. Okay, denser to less dense, I more than C, then only you get total internal. Okay. All right. No questions. I think that is all we need to mention today. Okay. I hope you learned something, and also trying to spend some time doing these questions definitely will help you in the exam. All right. The answer I say one last time. Now, if you are my students, right, I'll post in GC. If you are not my students, it's okay. You also can get answers from the TDC website. I sure got answer one. Relax, okay? There will be answer posted. Okay. All right. Any questions before I call it a day? Page 15. There you go. 15 here. If you have no problems, then you can leave already lah. That's it for today. Okay. And if you have if you have any questions, you can ask me. Okay, bye-bye. See you guys. Bye.